Hi there, my name is Branko, but you can call me Caillou, and today I will show you 3 ways to impress someone using mathematics. I will divide these 3 ways in increasing order of awesomeness. So with level 1 you can impress any friend or any family member. With level 2 you can surprise a student majoring in mathematics or physics. And with level 3 you can shock a mathematics graduate student, maybe even a professor. Now, of course, there are more than 3 ways you can impress someone using math. But throughout my academic life, these are for sure 3 facts that amazed me the first time I heard about them. Now, as my friend Mario would say, here we go! Level 1, 0.9 periodic versus 1. First of all, let's clarify something very important here. This number is definitely not equal to 0.9 periodic. When we have repeating decimals, this means that the number below the bar is infinitely repeated. That is the key, infinitely repeated. So what do you think? Is 1 equal to 0.9 periodic? Turns out they are exactly equal. I mean, if they weren't, why would I be including this in the video? They are just 2 different ways of writing the same number. There are several ways to show this, but the following one is my favorite one. We know that 1 over 3 is exactly equal to 0.3 periodic. This is a fact. Ask Google or your calculator. Well, if we multiply both sides by a real number, the equality should hold. So let's multiply by 3, for instance. 1/3 times 3 is equal to 1. 0.3 periodic times 3 is equal to 0.9 periodic. Voila! 1 is exactly equal to 0.9 periodic. Level 2. Abel-Ruffini theorem. When we are kids, we all learn how to solve polynomial equations of degree 1. These are just mathematical expressions of the form ax plus b is equal to 0. And we know that x will be equal to minus b over a. That is what algebra is about. We want to find out what values x can take. Then we grow up, and as teenagers we learn how to solve quadratic equations or polynomial equations of degree 2. So ax squared plus bx plus c equals 0. And to solve it, we use the super famous formula x equals minus b plus minus square root of b squared minus 4ac over 2a. This will give us 2 solutions for x, also known as the roots of the polynomial equation. When we focus on polynomial equations of degree 3 or cubic, so we have the form ax cubed plus bx squared plus cx plus d is equal to 0, these are the explicit forms of the roots of the polynomial. Yep. They are long, and it is very likely that this is the first time that you are seeing them. Usually they don't teach this in high school or even in university, because it's just about memory, right? It's just a long formula. For polynomial equations of degree 4 or quartic, so we have this form, these are the explicit solutions for the roots. You can see that they are a tiny bit more elaborate, eh? Yep, not done yet. Almost there, guys, almost there, come on. In the meantime, I can tell you a joke. What do you call an ant who fights crime? A vigilante. Okay, that was bad. Are we done? Okay, great. We're done. You now might be thinking that the roots of a polynomial equation of degree 5 or higher are just like messed up monsters. Well, in fact, there is nothing to worry about. Not for degree 5 or higher, because those roots don't exist. The proof is long, complicated, and it involves group theory. But if you want to dig deeper, I'll put a link in the description so you can take a look. But isn't that crazy? It's not that we haven't found a solution yet. Mathematicians have proven that it is impossible to find one. So if you want easy money, bet a friend that he or she can't find an exact solution to this equation. No approximations allowed. Level 3. I to the power of I. Ooh, this one is hands down my favorite one. I will go directly to the conclusion and not go into technicalities, because otherwise this level by itself would last more than 10 minutes. But for those of you who are interested, the proof involves polar coordinates, periodicity of sine and cosine, and Euler's identity, also known as the most beautiful equation in mathematics. There is also a link about this in the description. Anyways, we know that the number I is the square root of -1. It is what we perceive as the unit when we deal with complex or imaginary numbers. Leonhard Euler, one of the best mathematicians of all time, showed that I to the power of I is equal to e to the power of I times pi over 2 plus 2n pi, all of that to the power of I. So if we put the exponent inside, we will get that I to the power of I is equal to e to the power of minus times pi over 2 plus 2n pi. Okay, now it's the time when you have to fasten your seatbelt, because this is what's gonna be mind-blowing. What that equation is saying is that I to the power of I is a real number. Take a second to digest this. An imaginary number to the power of an imaginary number is a real number. In fact, I to the power of I has infinitely many real values. Just take any integer n and plug it in. You'll have a real solution. For instance, and this is probably the most famous form of I to the power of I, if we take n is equal to 0, we will get that I to the power of I is exactly equal to e to the power of minus pi over 2, approximately 0.2. Honestly, this is very, very cool. If you found one of these levels to be somehow interesting, leave a like and subscribe. Maybe I can do a second part of this video. Well, now you know how to shock someone using mathematics, so use this power wisely. I hope you enjoyed the video, and I will see you next time. Bye bye.